Dear friends, welcome to a new series where we will learn to build a Stoic character while uncovering the purpose of main algorithms, functions, and parameters in machine learning. Why Stoicism? Born in ancient Greece and embraced by Roman emperors such as Marcus Aurelius, Stoicism remains one of humanity's most enduring philosophies. It teaches discipline, integrity, and detachment from what lies outside our control. Contrary to misconceptions, Stoicism does not suppress emotions. Rather, it values community and honors positive emotions such as gratitude and joy. In business, Stoicism shifts focus from hype to long-term impact. In self-mastery, it builds resilience and leadership. In life, it cultivates clarity and initiative. In relationships, it fosters security and understanding. Stoic principles have maintained relevance across centuries and even inspire modern investment paradigms. In this series, we will blend ancient thought with the writings of contemporary philosophers, psychologists, business leaders, and strategists, while also deepening our understanding of machine learning concepts. How do we live a Stoic life? The Stoic path has three pillars: self-mastery, detachment from external influences, and interconnectedness. These mirror the dimensions of a machine learning model, or the attributes characterizing the data used in them. Let's start with self-mastery, or what Stoics call the unified rational self. The Stoics asked, who are we, and what should we work on in our character? This introspection resembles the data selection process, choosing what data to work with. Since we know ourselves, at least partially, our model reflects supervised learning as we are working with labeled data, our values, beliefs, affinities, and fears. The first step is data cleaning or removing irrelevant values. The single value columns point to outdated behaviors. Low variance features highlight low impact habits. Outliers signal disproportionate reactions to rare events. Missing values reflect blind spots in self-knowledge. Massimo Pigliucci advises daily reflection, planning in the morning, reviewing at night. Like the simple imputer, these routines fill gaps in awareness until deeper understanding emerges. Sometimes behaviors correlate. For example, procrastination and conflict avoidance may share a root. This parallels pairwise correlation in data, but selection also means identifying what matters most. In machine learning, this is feature importance. In Stoicism, the four cardinal virtues, wisdom, justice, courage, and temperance. Arius Didymus, advisor to Augustus, expands them into sub-virtues. Wisdom expands into good calculation and resourcefulness. Justice as fairness and commitment. Courage as perseverance and fearlessness. Temperance as moderation. These form our dataset for a virtuous life. The relationship between a sub-virtue such as good calculation and a virtue such as wisdom illustrates the correlation feature selection in machine learning. Stoicism also insists we focus only on what we can control. In machine learning, this is mutual information, where features reveal each other's impact. The process of shedding traits that don't serve us mirrors, recursive feature elimination, RFE, gradually refining our true character. Detachment resembles data scaling. Normalization reflects adapting calmly across varied situations. Standardization mirrors prioritizing values with consistency. Which algorithm suits the Stoic self? Classification separates traits to keep or drop. Regression forecasts how beliefs shape our path. Consider support vector machines, SVMS, embody Stoicism's view that events are neutral, interpretation defines them. Polynomial regression reminds us that growth is rarely linear. Though pressure increases, victories grow richer in meaning, like a Stoic boot camp of resilience. K nearest neighbors, KNN, recalls past challenges to guide resilience. Decision trees returns us to the core Stoic question: is it under our control? Random forest reminds us to consider multiple perspectives before judgment. Neural network helps declutter ego-driven thought patterns that blur our perception of reality. Generative adversarial networks, GAN, reflect our breakthrough as Stoics by transforming foreign but virtuous habits into second nature. Defining the dataset. Like ML models, we learn from a fake dataset, simulations of thought patterns and reactions. Functions include make classification, focus on thoughts, beliefs, affinities, and fears which could root toxic emotions. Make regression, envisioning our lives as Stoics. Key parameters: N samples, scenarios likely to trigger reactivity. N features, values or patterns influencing virtue. N informative, passions. Stoics opposed, distress, fear, lust, delight, and positive emotions they honored, caution, gratitude, joy, love. Noise, distractions irrelevant to virtue. Random state, consistency of responses across judgments, desires, and inclinations, or what Epictetus called the three types of act. Training and testing. We split data, 80% training, 20% testing. Training requires reflections on past responses, training set, and testing them against future experiences, test set. Model.fit mirrors, learning from past attachments. Model predict reflects our next response. Now let's evaluate our model. R squared, how much of life's variance can we explain? MSE highlights the weight of large errors, leading us to ask ourselves, did we integrate Stoicism into daily irritations? MAE points out sensitivity to outliers such as our resilience in relationships, career, or status. Classification report gives performance metrics like precision and recall, how often you're right or wrong about what you think you're attached to or affected by. Cross-validation tests your consistency across different life settings, such as work, friendship, or romance. If results look too good to be true, fine-tuning is required. Such optimization demands adjusting the learning rate, how fast we detach from toxic emotions, and epochs, how many experiences we need for mastery. We must also question training data. Did we identify all formative moments? In machine learning, we deal with Gini impurity, or the frequency to which an element might be mislabeled, and entropy, which measures the level of disorder or uncertainty within the dataset. Gini impurity is found when we focus on getting a prestigious role when in fact we're not looking for accolades, but work that we find meaningful. As for entropy, is this your true authentic self, or you operate from peer pressure, trends, or cultural norms? If we opted for a regression model, we may risk exposure to the bias error, oversimplified assumptions such as there will always be settings where we need external validation, or variance, adjusting our response to the perception we nurture of whatever stakes involved. Bias leads to rigid underfitting or stoicism mistaken for passivity, while variance to overfitting or overreacting to each situation. An ideal model has low bias and low variance. For that, we need regularization, which can be attained through the lasso and ridge methods. The lasso keeps only the most important traits. The ridge method keeps all traits, but balances their weight. When do we use each? Go for lasso when we believe some predictors are truly important, such as areas in our life where we're overly sensitive to external influence. Go for ridge when we have many predictors contributing to the outcome, like our impatience pushing emotions into a toxic pattern. Ensemble learning, strength in combination. To reach more reliable outcomes, we integrate multiple algorithms. Bagging splits training data into subsets, trains models independently, and combines results through voting for classification or averaging for regression. Nassim Nicholas Taleb advises us to build personal anti-fragility in diet, finance, and career. Self-discipline may extend on either tree areas. Bagging would therefore indicate its overall impact on our life. Key parameters we're going to work with in a bagging model include N estimators, or the number of base learners, such as using the KNN for past resilience or decision trees for control, max samples, or the number of training samples per learner. Let's think of the number of challenges needed for adaptability, bootstrap, or whether to sample with replacement. It's like contemplating whether an external pressure we cling to is worth enduring, base estimator, or the weak learner corrected by meta learner. This is how we avoid getting out of the anyone wants to be us trap. N jobs for parallel computation. This is essential to achieve detachment in one area of our life by assessing it against others. Is my career worth risking my family life? Boosting implies training models sequentially, each correcting the last. A key trap in our path to Stoicism is rigidity, whereas the ability to adjust appears like a fusion of all positive emotions, combining rational caution as well as wisdom. Jocko Willink teaches us to plan meticulously but execute flexibly. Think of boosting like our wisdom to constantly find areas to which we can adjust our strategy while using such insights to strengthen our initial plan. Boosting works with the following parameters: N estimators, or the number of weak learners. Since each weak learner comes to correct the other, let's think of how long does it take to learn that the only things within our control is our thoughts, opinions, decisions, and duties. Learning rate, which shrinks each new model's contribution, such as life teaching us, we can always get back on our feet. Base estimator, or the weak learner we used. Let's think of the model we used, predict our response to an event based on how we reacted in the past, even though we've learned better ever since. Max depth, mind samples split, or the model complexity control. Think of how many attempts to control the uncontrollable before cutting our losses. Subsample, what are we focusing on? Are we blinded by short-term wins on the expense of a long-term stable growth? Loss, or the loss function to optimize. In Stoicism, this is the best reminded for the toxic dimension of both fear and hope. Stacking, stacked generalization, trains different models and uses their predictions as inputs for a final model called a meta-learner. The k-fold cross-validation method is applied on each base learner model prior to the training dataset. This resembles what Jules Evans calls self-distancing, or see yourself from above, highlighting various perspectives such as the three types of act: judgment, desire, and inclination. We can blend those perspectives through a meta-learner that highlights how deep our Stoicism is. Key parameters to operate with when using the stacking model include base learners, or the different algorithms we use to assess where impulsiveness gets the worst of us. Meta-learner, or the final model trained on base learners' predictions. Can we truly master ourselves or just some impulses? CV, or cross-validation strategy for stacking. Must we always have the last word? Pass-through. Whether to include original features alongside base predictions. It's like focusing on identifying whether we demonstrated any of the 4 cardinal virtues in any circumstance. Continuous transformation. Stoicism is not a one-time choice, but a lifelong commitment. As Jocko Willink points out, fear is normal. Courage is acting despite it. Like model.transform, our mindset adapts continuously. The Stoic principle of arete teaches that happiness lies in human excellence, tempering impulses towards virtue. In machine learning, we test this with permutation importance, or measuring how much the model's performance degrades when a feature's values are randomly shuffled. In life, does ego undermine detachment? Another tool, mutual information, reminds us that while life throws challenges, the distinction between good and bad rests in how we apply reason and values.